Compound inequalities are expressions with two or more inequalities, but they're joined together with the words and or. So, for example, you could have x is greater than or equal to negative 3, and x is less than 2. Another example could be x is less than negative 6, or x is greater than 5. They're two inequalities put together or joined within one sentence. So when two inequalities are joined with an and, they are often written simply as a double inequality. So you guys would take the x is greater than or equal to negative 3, x is less than 2, and make it one big inequality with x in the middle. Greater than negative 3, less than 2. In between negative 3 and 2. So the solution of these and inequalities is actually the intersection or the overlap of each individual inequality in the sentence. Because what's going to happen is they're going to go towards each other, and that overlap, just sort of like when you guys used to, when we shaded the regular inequalities, it's the overlap that's the solution for both. So to find the intersection, determine where the two graphs of the sentence overlap. On a number line, you would just shade the middle. You're not going to shade the whole number line, just the overlap part, or the part between the two values. So the solution of an or inequality is called a union. So it is the union of each individual inequality in the sentence. And we'll talk more about unions later, but in an or inequality, you solve for each inequality separately and then just actually put the two solutions on the same graph. So there won't be an overlap here. It's this solution or that solution. This solution for this one, this solution for that one. There's not an overlap for or. There's just an overlap for and. So when you guys graph these, it's going to be the outside of your two values. So they will go away. So outsides go away, or ors go away from one another, and ands will go towards and overlap. So if it wants us to graph the following, x is greater than negative 2 and x is less than 3. So I'm just going to put 0 somewhere in the middle here. So 2, 4, 6, 8, negative 2, negative 4, negative 6. Okay, so they're both just greater than, so they will be open circles. So we have, I just plot my points first, or my circles. So negative 2 and 3. You guys can choose to put them on the number line, above the number line. It doesn't really matter to me as long as I can read it and it's legible. So greater than negative 2 would be to the right of negative 2, but less than 3 would be to the left. So because it's an and, that does follow the rule, and it's in between negative 2 and 3. Okay, so graph x is less than negative 2 or x is greater than 3. So still the same values on my number line. Still both open dots at negative 2 and 3, but it's less than negative 2 and greater than 3. So or out and in. That will always be the case. Now there are several different ways that we can sort of write or express compound inequalities. So we can write them in inequality notation, which is what we sort of just looked at, interval notation, and we also looked at the graph. So the really only new one is going to be that interval notation. So we're going to just say, we're going to use A and B, and they're going to be our two number values. So we could write an inequality saying that this number, I'm just going to choose X for my variable, is greater than or equal to A and less than B. So, because it's an and, X is going to be in the middle between A and B. So it's greater than or equal to A and less than B. So I know that sign that first sign sort of reads less than, but because X is on the right hand side, it's open towards the greater side. So it's sort of flipped. What you guys have to remember is that both of your inequality signs will always point to the left. They should always be going that direction. One shouldn't be going left and one's going right. They're always going to go to the left, assuming that you've started with the less value going from left to right. So the lowest value should be on the left, highest value should be on the right. So that's inequality notation. You guys would know how to graph that. So on your number line, and I don't know what A and B are, so I'm just going to put them down here. Greater than or equal to A, so that's this way, but less than B. So notice, because we have two different signs, we have two different circles. One is open and one is closed. And that is fine. They don't have to be the same. So the interval notation is the new one for you guys. So before I write the interval notation, I'm going to go down here and talk about it a little bit. So if your inequality is less than or equal to or greater than or equal to, we need to include that value as part of the solution. So including would mean a closed circle, but in interval notation, we would use brackets, the square parentheses, if you will. Now, if it's just less than or greater than and not equal to, the solution is not included with that value, so it's just going to be parentheses. I'm never sure if I'm spelling parentheses correctly or not. So, when we're doing this interval notation, which one is closed, which one is open, which value gets bracket, which one gets parentheses? Do they both get the same? Is one different? So, A is closed, so that would include our solution. So it's going to go from left to right, and I always like to look at my number line or my graph. It's going to go from A to B. A is included, B is not. A gets the bracket then, B would just get a parentheses. So I think it's always helpful to do the number line or the graph first, then do interval notation. So to do two examples, we're going to do B and D. B says X is less than or equal to 5. So we can literally just write X is less than or equal to 5. So I would come over here and do the number line first. I'll just put 5 in the middle, 6, 4. So close the open dot. It's or equal to, so it needs to be included. And it's less than. So we're going to go to the right. Again, you can put it on top of the number line. That would be fine. So from left to right, if it's continuing forever in that left direction, it's never actually stopping. It's including every single number possible that's less than or equal to 5. So if it can go on forever, that furthest left is ever really reaching is going to be negative infinity. We want to include all numbers to the left. And where is it stopping? At 5. Are we including 5? Yes. Parentheses will always be at your infinities, guys, because infinities can never actually be reached. We just always approach that negative infinity value. So let's look at D. X is greater than or equal to 0 and less than or equal to 9. So because it's an and, X will go in the middle. Your lowest value goes on the left, your higher value goes on the right. So 0 and 9, and it's greater than or equal to 0, less than or equal to 9. So on your number line, I'm just going to put the two values here. Both closed dots, because they're both included, they're both equal to, and in between. So, interval notation, the furthest left this inequality goes is 0. The furthest right it goes, or the highest value it goes to, is 9. Are we including both of those values? Do they both have closed circles? Are they open? What are they? They're both closed, so they will both get brackets because they are both included. So we're going to do more of the same thing. It's just that they give us the number line now instead of the sentence. So because I see that this is two separate pieces here in number 3, I know that it is an or inequality. So I have to write two separate ones. So my first inequality will be less than 7 because it's going to the left and there's an open dot there. So X must be less than 7, or X must be greater than or equal to, because of the closed dot, 11. So that's my inequality. And my interval, this is that one where we're going to use a union that we sort of talked about in that first paragraph. Because union means that there's a gap. There's a space where the solution isn't included. So the interval is going to go from left to right, all those negative values. So it comes from negative infinity and stops there at 7. We don't include 7, so we need a parentheses. We skip all those values in between 7 and 11 because they're not part of the solution. And then we pick back up at 11 and go to include all the positive values. 11 is included. 11 gets a bracket. So all that union means is that there's a space or you're skipping a value. So there's a space or a gap in your solution. So for number 4, this is an and because it's in the middle. So it goes from 0 to 4. 0 is closed, so it needs to be included. Four is open, so that's not included in the solution. So 0 is our lowest number, 4 is our highest number. We're just going to call the value X. Is in the middle. Both of our signs will go to the left. Are they both just less than or just greater than, or are they equal to? Well, it's greater than or equal to 0, just less than 4. So that's it. So be paying attention to if you have closed or open circles. That will determine or tell you if you're using parentheses or brackets. And we're always going from left to right, greatest to, or least to greatest, left to right, least to greatest, lowest to highest.